Today we're going to be talking about the trig ratios on the coordinate plane on a graph. Okay, so let's introduce this to you. Let's consider the angle whose terminal side goes through the point 3, 4. So here's the point 3, 4. So that point is on the terminal side of the angle. So that terminal side must look something like that. The initial side is always right there. That's always the initial side. So the terminal side is here. Here's the initial side. It goes to the point 3, 4. So we're going to call this angle right here theta. Okay, call that angle theta. Lots of times kids like to put theta right up there, and it's confusing. Theta is not that ray. It's not the name of that ray. Theta is the angle right here. Okay? So we'll try to keep reminding you of that. Alrighty. We can form a right triangle if we draw a line segment from this point down to that initial ray, down to the x-axis, right? This length of that side is 3. This length is 4, which makes the length of that hypotenuse 5, right? Once we have those lengths, then we can find all of the trig ratios, ignoring the rest of that ray and just examining that right triangle. So sine of theta would be 4 over 5, opposite over hypotenuse. Cosine of theta is 3 over 5, adjacent over hypotenuse. Tangent is opposite over adjacent, so 4 over 3. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So we can pretty easily get those, right? Okay, this is a good time to talk about reference angles, because let's examine the angle whose terminal side goes through the point -2, 3. There's -2, 3. So they're saying that this, let me see if I can get this straight by using a little straight edge here. That's the terminal side of the angle, but the initial side of the angle is still, as it always is, the initial side is always right there. So this is theta. That is theta. Okay? To form a right triangle, though, over here, we're not going to use this theta here. Instead, we're going to drop this perpendicular right to the x-axis. So this is our right triangle over here. There's our right triangle. This leg is of length 2. This leg is of length 3, which means the hypotenuse, doing a little Pythagorean theorem, that would be the square root of 9 plus 4. So that would be the square root of 13, right? Okay. So we're going to be using this triangle to get the trig ratios, but theta is over here. This is where the idea of a reference angle comes from. The reference angle is the angle formed by the terminal side of the angle, theta, and the x-axis. So the reference angle here is right there. That's the reference angle. Okay? And that's going to help us determine these trig ratios. But what it's also going to do is, well, what makes it different from just using theta is that we can have negatives over here. Up until now, we've only had positive trig ratios. So now we're going to be able to have some negatives. Okay? This 2 That is the length of that leg, right? But since it's going to the left of the origin, I'm going to give it a negative. It's a -2. All right? It's going to help determine. Now the 3 is going above the x-axis, right? It's going above, so the 3 keeps its positive. And this hypotenuse is always positive. Always. No matter where you're at, the hypotenuse is always positive. Okay, so let's use this and get sine of theta. Sine of theta, we're using the reference angle. Sine is opposite over hypotenuse, 3 over square root of 13. Rationalize, and we get 3 square root of 13 over 13. Cosine of theta. Well, cosine is adjacent over hypotenuse. If this was just a triangle, not in the coordinate plane, that would not have a negative on it, would it? It would just be a 2. If I just gave you a triangle, this would not be a -2 length. It would be 2. Right? But we are on a coordinate plane. This is theta. Cosine of this reference angle is going to be a -2 over square root of 13. Which one rationalize is -2 square root of 13 over 13. Okay? That's how that works. That's how that reference angle works. Okay? Reference angles are always positive. Reference angles are always positive, and they are always less than pi over 2, which 90 degrees, okay? And you always use the terminal side and the x-axis. Always the x-axis. It always goes between the terminal side and the x-axis. Never the y-axis. Never. Okay? All right, tangent of theta. Tangent of theta, opposite over adjacent. 3 over -2, or -3/2. Cosecant of theta. Cosecant of theta is the reciprocal of sine of theta, so square root of 13 over 3. Secant of theta is the reciprocal of cosine of theta, so negative square root 13 over 2. Cotangent theta is the reciprocal of tangent of theta, so -2/3. Okay? Reference angles. So let's talk a little bit more about reference angles. Find the reference, by the way, before I go on, this terminal side was in quadrant 2. This is quadrant 2 up here, right? Let's notice something. Sine and cosecant were both positive, but everything else was negative. In quadrant 2, that is always the case. Sine and its reciprocal will be the only positive ones. The others will be negative. In quadrant 1, up here in this first example, notice that this was the terminal side. There's theta. In this case, in quadrant 1, theta is its own reference angle. Okay? So only in quadrant 1 does that happen. And everything was positive. So in quadrant 1, all of the trig functions are positive. In quadrant 2, only sine and its reciprocal are positive. We're going to do quadrants 3 and 4 in a moment. But first, let's do a little bit more on reference angles, because this is something I need you to get right. Okay? Let's find the reference angle for this angle, 7 pi over 4. We know where 7 pi over 4 is. 7 pi over 4 is down in the third quadrant. I'm sorry, the fourth quadrant. So this would be that terminal side. This is the initial side, right? But the angle goes all the way around like that. That's 7 pi over 4. 7 pi over 4 isn't right here. It's not the name of that line. 7 pi over 4 is the angle, right? So the reference angle is always from your terminal side to the x-axis. So this is the reference angle. I'm going to abbreviate that REF with a little angle symbol, right? So what is that angle? Well, if all the way to here was 7 pi over 4, then what's left is going to be a pi over 4. So the reference angle for 7 pi over 4 is pi over 4. Let's do it for pi over 3. Pi over 3 is in the first quadrant. There's the terminal side. Here's always the initial side. So there is pi over 3. But the reference angle is always from the terminal side to the x-axis, which is exactly pi over 3. It's still the same. So in quadrant 1, the reference angle, I might even put down here, it's like also the reference angle, pi over 3. Okay? Let's do 6 pi over 11. 6 pi over 11. Which quadrant is 6 pi over 11 in? Well, if it was 11 pi over 11, it would be at pi. 11 over 11 would be here. We're at 6 over 11. Is that bigger than half of 11? Yes, it is. It is bigger than half of 11. A little bit bigger than half of 11. Half of 11 would be 5.5, right? We're at 6, so it's a little bit bigger than 5.5 pi over 11. So this is 6 pi over 11, right? I should continue that. Okay, but the reference, the initial side is still there. So there's 6 pi over 11. The reference angle is always from your terminal side to the x-axis. So right here is your reference angle. What is its measure? Well, it would be what's left after the 6 pi over 11 until you get to pi, so that would be 5 pi over 11. Okay, so that's how reference angles work. Okay, let's go back. Oh, I gotta pet the bunny for a second. I'll be right. Okay, I'm back. I'm still taking care of my daughter's bunny. I'm making a bunch of these videos over the summertime, so anyway, this is what's going on. All right, so right now we're going to determine the sine of sine theta, cosine theta, and tangent theta, and their reciprocals, if theta is in these quadrants. So we've already examined quadrant 1, and we know that they are all positive here. They're all positive there. So again, to show why they're all positive there, if I have a point there in quadrant 1, this distance, this side would be positive, and if we go to the right of the origin, that length is positive. That side is given a positive value. If we go above the x-axis, it's given a positive. The hypotenuse is always positive. So no matter what combination we have for these sides, they are all positive, right? All positive. Over in quadrant 2, we did this one. In quadrant 2, here's your triangle. Okay. The hypotenuse is always positive. This side of the triangle is above the x-axis, so it's positive, but this side of the triangle is to the left of the y-axis, so it gets a negative. So any trig ratio that has adjacent in it will need to be negative, right? So which trig ratios have adjacent in it? Cosine and tangent. So cosine and tangent and their reciprocals will need to be negative. Sine, positive. So sine is positive here. Okay, it's the only positive one there, and it's reciprocal, cosecant. Alrighty, let's go to quadrant 3. So in quadrant 3, we would be down here. Here would be our triangle. Okay. This side is still to the left of the y-axis, so it's negative. This side is below the x-axis, so it's negative, but the hypotenuse is always positive, right? So, sine of that theta would be opposite over hypotenuse. That would be negative. Cosine of theta would be adjacent over hypotenuse. That would also be negative. What about tangent? Tangent would be opposite over adjacent. A negative over a negative is a positive. So sine and cosine and their reciprocals would be negative. Tangent and its reciprocal, cotangent, would be positive. So tangent is the only positive one there, and its reciprocal. Okay, you can probably guess what's going to happen over here in quadrant 4, but I'm going to finish this off here. Alright, so this side is to the right of the y-axis, so it gets a positive, but this side is below the x-axis, so it gets a negative. The hypotenuse is always positive, so only the trig functions that include the opposite side will be negative. Cosine is adjacent over hypotenuse, so cosine is positive. But tangent is opposite over adjacent, it would be negative. Sine is opposite over hypotenuse, so it'll be negative. So only cosine is positive in quadrant 4. So let's summarize. All positive in quadrant 1, only sine and its reciprocal in quadrant 2, only tangent and its reciprocal in quadrant 3, only cosine and its reciprocal in quadrant 4. This is important stuff. You're going to use this all the rest of the year and all through calculus. Okay? One way to remember it is with this mnemonic device. All students take calculus. All is for all trig functions. S is for sine and its reciprocal. Take is for tangent and its reciprocal. Calculus is for cosine and its reciprocal. Okay, so we are going to be using that the whole rest of your math career, however much longer you're doing math. Hopefully it's going to be for a long, long time. You're going to be using that. Okay, it's not going anywhere. So let's take a look at how you might be given something like this. So let's take a look at this problem. So if tangent of theta is negative 8 over 15, and sine of theta is less than 0, what is secant of theta? Well, this tells me that tangent is negative and sine is negative. So what quadrant must we be in? If tangent is negative and sine is negative, what is the only possible quadrant? It has to be quadrant 4. It has to be. So I'm going to draw this in quadrant 4. I'm going to put a point down here in quadrant 4. I know that's where we're at. Now I'm going to make the triangle there. I'm going to draw my terminal side, and now I'm going to draw the other side. The other side never goes to the y-axis. The other side always goes to the x-axis. Always. Okay? Remember, you guys, that this is theta. That's theta. That is the theta in question. Okay? However, we are using the reference angle to get those values. That's the reference angle. Always to the x-axis. Okay, so they told me that tangent of theta is negative 8 over 15. I know that tangent is opposite over adjacent. So 8 over 15. So I'm going to put those ratios here, opposite over adjacent. But what do I do with that negative? Which one gets the negative? Not both, because if it was both, I would not be down here in quadrant 4. Only one of them gets the negative. Which one is it? It's the 8, because it's going below the x-axis. The hypotenuse, what would be the value of that hypotenuse? What is that Pythagorean triple? That's an 8, 15, 17 right triangle, so that's the hypotenuse. So what is secant theta? Secant theta is the reciprocal of cosine theta. Cosine theta is adjacent over hypotenuse, so secant theta is hypotenuse over adjacent, 17 over 15. That's that answer. I'm talking all the way through it. It's not going to take you nearly that long when you're doing it, but I wanted to talk all the way through it, and I will probably continue to talk all the way through this for the sake of your notes. Okay, let's do another one, number 3 here. If secant of theta is 13 over 12, and tangent of theta is less than 0, what is cosecant of theta? All right, well, this tells me that secant is positive, which means cosine is positive, true, and tangent is negative. So which quadrant must we be in? We must be back in quadrant 4. It's the only possible quadrant. So I'm going to draw my angle down in quadrant 4 again. Here's my initial side, here's my terminal side, and here is theta. I want you to remember that that is theta. Theta is not that name of that line there. So the reference angle is right here with the x-axis. There's our reference angle. Okay, I'm going to finish the right triangle. And now, we are given that secant of theta is 13 over 12. Well, secant is the flip of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. 13 over 12. Okay? So that means, what is this leg over here? Well, I know it's going to be a 5, but it's going below the x-axis, so I'm going to apply a negative to it. It's going to help me remember my signs. Okay? So, cosecant of theta is the flip of sine of theta. Sine of theta is opposite over hypotenuse, so cosecant of theta is hypotenuse over opposite. 13 over negative 5, or negative 13/5. Okay? Number 4. This time, they give me that cosecant of theta is 5 over 2, and they told me what quadrant theta lies in. Theta lies in quadrant 2, so I'm going to draw it in quadrant 2. Okay? There's the terminal side of the angle theta. Here's the initial side of the angle theta. This is theta. So where is the reference angle? Right here. So I'm going to finish my right triangle, and I'm going to mark my reference angle right there. Okay? Cosecant. Cosecant is the flip of sine. Sine is opposite over hypotenuse, so cosecant will be hypotenuse over opposite. 5 and 2. Okay? we can use the Pythagorean theorem to get this side. So in my head, I'm doing the square root of the square of the hypotenuse minus the square of the other leg. So that's going to be the square root of 21. Okie dokie. So we found our other side here, and now we are going to find cosine of theta. So cosine of theta, we're using the reference angle. Cosine is adjacent over hypotenuse. So square root of 21 over 5. Is that correct? No, it is not correct, because in quadrant 2, cosine is not going to be a positive. So a couple of ways that you can remember this. Either when we wrote the square root of 21, we have to notice that it's to the left of the y-axis and give it a negative, or just remember in quadrant 2, cosine will have to be a negative. And so give it to either give the negative here or wait till the end and give it, but somehow give it. All right? Alrighty. Number 5. Sine of theta is -3/5. Theta lies in quadrant 4. So I like it when they just go ahead and tell me where it lies. And it says lies. Really and truly, I'm going to fix this on your notes. It should say terminates. It doesn't lie there. It should say it terminates. So I'm going to fix that in your copy. It terminates there. All right, so I'm going to draw that ray terminating in quadrant 4. Here's the initial side. So there's theta. The reference angle is with the x-axis. So I'm going to draw this. I need to get my values. Sine is opposite over hypotenuse, so 3 and 5. One of them gets a negative. I give it to the 3. The hypotenuse is never negative. So that means this leg over here must be 4. Is it positive or negative 4? It's positive because it's to the right of the y-axis. So what is tangent of theta? Tangent of theta, opposite over adjacent, -3 over 4, -3/4. Number 6. Tangent of theta is positive. And look how they gave us the information this time. They say theta is between pi and 3 pi over 2. Which quadrant is between pi and 3 pi over 2? That is quadrant 3. So we are down here, quadrant 3. So we're terminating there. We are starting over here. So this is theta. There's theta. Where is the reference angle? This is the one where kids always want to put it to the y-axis, and it's not. It's not to the y, because it's never to the y-axis. The reference angle is right here. There's your reference angle. So we're going to draw the triangle always to the x-axis, like that. Okay, there's your reference angle. Tangent is opposite over adjacent, 1 and 3, right? But the 1 is below the x-axis, the 3 is to the left of the y-axis. So if you want to, you can give these both negatives here, or you can wait and apply your sign at the end. The hypotenuse, it'll be the square root of the square of -3 plus the square of -1. The square of -3, so let me write that down. -3 squared is 9. -1 squared is 1, so this is the square root of 10. And remember that the hypotenuse is always positive. So now we can find cosine of theta. Cosine is adjacent over hypotenuse, negative 3 over square root of 10 when we rationalize negative 3 square root 10 over 10. Okay, before I leave you, a couple more little reference angle questions. Which of the following is the reference angle for 14 pi over 9? 14 pi over 9. Well, which quadrant is 14 pi over 9 in? 14 is bigger than 9, so I know it goes past pi. But 14 is not double 9, so it's somewhere between pi and 2 pi. Does it go past this halfway mark? Does it go past there? So this would be 9 pi over 9. This would be 18 pi over 9. Which is 14 closer to? 9 or 18? 14 is closer to 18, right? So that makes our angle terminating in quadrant 4, right? So here is 14 pi over 9. Which means the reference angle, always to the x-axis, is right there. So how much is left? After you go 14 pi over 9, how much is left until you get to 18 pi over 9? 4 pi over 9. That's the reference angle, B. Okay? By the way, I knew that it could not be 5 pi over 9 or 7 pi over 9 because both of those are bigger than 90 degrees, pi over 2. Those are both bigger than pi over 2. A reference angle will never be bigger than pi over 2. Never. Let's take a look at number 8, the last one here. Which of the following is the reference angle for 13 pi over 10? 13 pi over 10. Well, 13 is bigger than 10. This would be 10 pi over 10. 13 is bigger than that. Is it past 3 pi over 2? No, because this would be 15 pi over 10. 3 pi over 2 would be 15 over 10, yeah? So 13 is between there. So here is theta. That is 13 pi over 10. That angle is 13 pi over 10. So where's the reference angle? It's always between your terminal side and the x-axis. So there's your reference angle. What is that angle? It has to be 3 pi over 10. If the whole thing is 13 pi over 10 and this is 10 pi over 10, then this has to be 3 pi over 10, B. Okay, and that is our notes on trig ratios on the coordinate plane with an emphasis on reference angles.